Welcome to 1.3. This is page 5. Hopefully you're up to speed with the other pages, and we are going to just get started. Use a graphing calculator utility to graph the function. Okay, we can do that. Let's start with 36. We got 3x squared minus 2x minus 5. I'll keep it in zoom standard, zoom 6. And we've got a parabola. And relative maximum, relative minimum. It means you're like, for a relative minimum, you're the lowest point in an interval. Doesn't mean you're necessarily the lowest point on the graph. For instance, this point right here has a relative minimum here and here. Likewise, a relative maximum here and here. This is not necessarily the minimum of the graph. In fact, the minimum of the graph appears to be going down forever, but it has, if we talk about the value of the houses, this has houses that are worth more to the left and more to the right. This relative maximum has houses that are worth less to the left and less to the right. Therefore, relative to its surroundings, it's a maximum. So we have a relative minimum right here, and there are algebraic ways to find it, but we don't have to do that today. So we're going to go into calculate, which is second calculate, and we're going to look for that maximum. We've done some of this, or minimum, excuse me, minimum. I'm already to the left of the minimum. It wants a left boundary. We hit enter. It wants a right boundary. Don't flirt with it, just get past it. Make sure you're past it because you'll get a false answer. And now guess, give me the value between. We have what appears to be a relative minimum of -5 1/3, 0.3 repeating, but it's probably preferred 1/3, at x equals, this is probably 1/3, probably. It's definitely worth assuming. And that's it. We don't have a relative maximum on the graph. Okay, number 40. Clear, we got x, second square root, 4 minus x. We ought to be becoming fairly adept at kind of recognizing a bivox here. 4 is going to be a pretty interesting value on the graph because the graph just appears, well, the graph will appear to die there because I can't put in 4.1 or 4.2. I could put in 3.999. I can put in 4, but we would have problems with that square root. Let's go ahead and graph this. Keep it in zoom standard and expect something interesting to happen around 4. And sure enough, something interesting happens at 4. And not just that, the calculator's giving us a little bit of a lie here because it looks like it's just suspended above 0. But I can look algebraically. If I put 4 in here, I get 0 times 4. You can confirm that by going second calc. I'm going to go value, and I'm just going to enter 4. And it says, yep, that's actually on the graph, even though we don't show it. If I step to the right of there, whoops, I'm not in trace. If I go back to trace, if I step to the right of there, anything to the right of 4 does not exist. Anyway, we have a relative maximum right up here. Now we don't have a relative minimum. Oh, by the way, we're supposed to be graphing these. We're supposed to draw a graph. This one looked like this. And this one should look like that. So we have a relative maximum here. We would not call this a relative minimum here because it's not lower than points to the right of it. There are no points to the right of it, so it can't be lower than points to the right of it. So all we have is a relative max of, let's find it, second calc maximum. Make sure you're to the left of it. Make sure you're to the right of it. Sorry about that. Must have hit a button there. Make sure you're to the right of it. Guess. Yep, we'll guess. And looks like 2 2/3. So relative maximum of this isn't a very pretty value. 3.079. And I've said this a couple times, but we're going to round to 3 decimals unless we can recognize a fraction value, or unless otherwise specified. Its relative maximum is the y value. Its maximum is 3.079, and that occurs at, I believe that is 2 2/3. You could go 2.667 on an AP exam, and they would count that correct. Okay, 44. Negative x to the, we use that caret key, to the third. I guess I better get rid of some of this other stuff. Delete, plus 3x squared. And we'll try that in Zoom Standard. Show the graph. It appears as though it has a minimum at 0, 0. Let's let our calculator confirm that for us, and I will bet you that x value of that point is not listed as 0. I might be wrong, but it won't surprise me if it's some rounding error. Let's go second calculate. Let's find that minimum. Let's get to the left of it, enter, get to the right of it, enter, enter. And there it is. There's that rounding error. That's negative 0.000009. It's 0. So it has a minimum, and this is 0. Likewise, this is most likely 0 as well. So we have a relative minimum of 0 at x equals 0. Then we have a relative maximum over here. And we could have multiples of both of these things. So second calc max, pretty straightforward here. Get to the left of it, close but not so close that you know you're beyond, that you might be beyond the maximum, excuse me. Get past it. Guess, and it looks like 4 at 2. We have a relative maximum of 4 at x equals 2. And there it is. Okay, and now we've got these piecewise functions, where again I look at these as a factory where you put things in, but it has 2 different output types. In this case, 3 different output types for this one. So depending on what the value of x is. So how I would do this, as I'm just starting doing these things, I might t-chart these things. I'm going to call this A and this B. So in A, the value I would put in A first would be this negative 4. When I put in negative 4 in here, it's less than or equal to negative 4, therefore it gets this treatment, negative 4 plus 6, 2. And then I'm going to continue on A. So here's my y value. This is like function A. That's really what I'm putting in for x. We'll call it A up here. Okay, so I'm not going to put in negative 3 because it wouldn't go into the half of the function that I've designated as A. So I'm going to go to negative 5. When I put in negative 5, I get 1. And I can put more points in than that if I like. However, I know that this is a line with slope 1, y-intercept 6. It's trying to aim up at 6, but it can't get there. But it can continue down with that slope 1 in that direction. And now our little semi-function B, this might seem a little odd at first, but I'm actually going to put negative 4 in here. because I can put in negative 3.9999999. So when I put in negative 4 here, I get negative 12, negative 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All the way down here. When I put this in, I get that, but I don't quite get to touch that. And then from there, I'm going to put in values to the right of there. So I put in negative 3, and I get negative 9, negative 13. Negative 9, negative 13. Negative 3, negative 13. So we're right in here. And I can go back and I can take a look, and I'm like, yeah, you know what? This is just a line with slope 3, y-intercept negative 4. This is going to look like y-intercept negative 4 is going to look like that. Okay? So we're going to take advantage of the fact that these things look like lines, and we're going to expedite that process just a little bit. So here we go. Let's go ahead and we'll just call this one A, B, C. For A, I want to put in negative 3, and when I put in negative 3, I get 2. And I actually truly get it because we're allowed to put negative 3 into this. So it gets a solid dot. And this has slope 1. It would really be trying to go through that point right there. Well, actually it would be up 3 from there. But it's slope 1. By the time it comes down 2, it will go down 2. So I don't have to pick a whole lot of points because I know what the lines look like. And then from negative 3, not including negative 3 to 1, the graph is just 5. So watch this. At negative 3, 1, 2, 3, 4, 5, we jump up to here, open circle, because negative 3 actually gets treated with A and not with B. But negative 2.99999 bumps up against it. And that happens until we get to 1, but not quite to 1. We're right through here. Open circle. And then after that C, we put in X, we get out Y. First value I'm going to put in there, maybe the only value I'm going to put in there, is 1. I put in 1 and I get 5 minus 4, 1. And I truly get it. And then we're on a line with slope of 5, up 1, 2, 3, 4, 5 over 1. There's our piecewise function. Kind of strange, perhaps new for you. Pretty manageable. It's just a way for them to make us graph 3 graphs in 1. So there you have it. Fairly quick page. Let me know what I can help with.